So this video is going to show you how to use the aluminum beam calculator that's been produced by Sunny Engineering. This calculator is intended for use by people in the solar industry who are trying to reduce the number of penetrations and the amount of material that they're using, mostly in their solar tilt racks. This works with aluminum angle irons, and you can enter in your own angle iron. I've pre-entered a few sizes that are fairly common. This is a 2x2 by 3/16 thick, and the aluminum grade is 6061 T6. This entry here is just the title. Anything that's in yellow here are things that you're going to be able to change to suit the specifics of your job. The rest of this calculator in the lockdown version are not going to be changeable, in the free version I should say. So you can change this to a 3x2 and make that a 1/4 inch thick. You can also change this information here, which is going to relate to the different grades of aluminum that you have. These values are pulled from the aluminum design manual, and these values here are just valid for the 6061. This calculator doesn't work with tempers less than T5, so it will work with T5, but it does not work for T4 or lower. So these boxes here are unlocked, so you can change anything that they say. You can put dates or page numbers or anything you want in those boxes. And these are values that are going to change per job, so obviously that's going to be where the usefulness of this calculator is. And I'm just going to explain each of these entries to help you in using this calculator. The first one is the maximum spacing between lateral supports. Now, if I'm going to scroll down, right here. This is the orientation of the aluminum rail. It only works, this calculator, if the aluminum rail is oriented with one leg both horizontal and up. If the rail is inclined more than 10 degrees, then this calculator starts to become fairly inaccurate and will over-report the strength. So that's something that your engineer is going to have to be aware of when they work with it. So this is just kind of what your angle iron is going to look like. And mounting to the top of this, right, in this area are going to be your solar rails, and they're going to keep your aluminum rail from shifting right, left and right. That's why they're called lateral supports, because they support it in lateral dimension. So the maximum rail span, this is usually what you're trying to optimize. Now, if you look down here, we're failing in deflection. We've got 1 inch of deflection, which exceeds what I'm using for the deflection limit is L/120. Deflection limits in the solar industry are not yet really agreed upon, but this is a fairly reasonable deflection limit. In a 72-inch span, if you get an inch of deflection, that's not going to be the best. So anyway, maybe we want to turn that down. Let's see if we can do 52 inches. Oh, yep, 52 inches works, no problem. The other thing that you could do if you really wanted, some longer span is you could change this to a stronger rail. That reduces deflection some, but not enough. So maybe do 80 inches. There we go. That brings everything. What you're looking for is that all these things be less than 100%. And in this version of Excel, I've got it set up that if it's less than 100%, it's green. So green means go. All right, what's next? The tributary width to the rail. That's usually going to be the spacing between the rails. So if your rails are spaced 48 inches on center, then have that value as 48 inches. This is the unfactored wind uplift. I'm going to be releasing a calculator in the near future that's going to help you with this calculation as well. And the wind downforce will also be in that calculator. The dead load for a flush mount is usually about 3 psf. For a pipe rack, it gets to 4 or maybe 5 psf. But again, the weight of the dead load is going to be fairly minor compared to the wind, and in areas that have snow, those snow loads are usually pretty dramatic, as you can see by all of the red that's showing up here now. So, I didn't put the summary at the end. I think it's better to have the summary right next to these values so you can, play around with the design values of your system, and then see right there what it is that you're reporting. The rest of this is all locked down engineering calculations. You don't need to really worry about these. These are there for checking mostly. When this goes to the building department or before the engineer stamps it, he's going to want to review these calculations and make sure that they're working. But generally, anything here that says positive flexure, that is the moment resulting from forces down, such as wind down or dead load or snow load. Those are going to increase your positive moment, and the negative moment is going to be mostly due to the wind uplift. And if any of that is Greek, well, that's fine. Just, if these values are entered correctly, then you're going to get a good idea of what your engineers have to accept from what comes here. Yeah, unlocked versions of this are available for, it doesn't cost much, and it also is provided without any warranty, and nobody's liable for anything unless it's been stamped by a professional engineer. And I've listed the assumptions that this calculator works under here. I guess the units isn't really an assumption, but you should only use 90-degree angles with the orientation like this, with one leg horizontal and as hot, up, one leg closer to the sky. And I've assumed that bending occurs about the geometric axis, which that's why this calculator is not going to work when you have inclinations on your rail greater than 10 degrees. As I mentioned, T5 or greater. Don't really need to worry about that. And then all this stuff here is just logic that is helping to run the equations above. So I hope you find this calculator useful. If you're using some other kind of rail other than an aluminum single iron, I'm really interested in producing a calculator for that. So please contact me. This is going to be posted to YouTube, so you can contact me through YouTube, or I'm, as shown here, david@sunnyengineering.com. Thank you very much, and I'll be uploading more good stuff later.